In this video, I'm going to solve the problem 23rd from chapter 19. So here, I'm going to solve the first three subdivisions in this video. Figure shows an cycle undergone by 2 mole of an ideal monoatomic gas. The temperatures are T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin. For the state 1 to 2, what are the heat and what is the change in internal energy and what is the work done? So here you have to see the figure representing the graph, and here the graph drawn pressure versus volume. And in this graph we mentioned three different states: state 1, state 2 and state 3. And all these three states are different temperatures. Clear? So here I'm going to solve the problem for state 1 to 2. That means you have to see the arrow mark which is moved from the number 1 to 2. So for this we are going to calculate what is the heat and what is the internal energy change, and then we are going to find what is the work done for this state 1 to 2. Clear? Okay. First of all, I'm going to write what is the given, so better we can write one by one. So the number of moles here they mention as 2 mole, and then temperature T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin, right? Okay. And here we are going to find the answer for the three questions. In the first part, we are going to find the answer for the heat energy transfer. And in the second part, we are going to find what is the change in internal energy. And in the third part, we are going to find what is the work done. And for this, they clearly mention this is monoatomic, right? So you have to read the question carefully. Clear? So if you read the question, they clearly mention this is a monoatomic gas. Clear? Okay. Now we have to find the answer for these three. And first of all, we have to see the figure. From state 1 to 2, you have to see there is no change in volume. That means from state 1 to 2, it's a constant volume. If it is a constant volume, there will be no work done, right? So you have to see the figure from the number 1 to 2. It's exactly a straight line. That means here you have to see what is in the x-axis. In x-axis they represent the volume. So from state 1 to 2 there is no change in volume. That means it clearly represents the state 1 to 2 represent the constant volume region. So I have to write here for state 1 to 2, the process takes place at constant volume. Clear? And for this we are going to find what is the heat energy. So let's start one by one. I'm going to find the answer for the first question, amount of heat transferred. And here it is a constant volume, so we have to write the rule related to molar specific heat at constant volume. We already studied the rule in the theory, which is Q equal to N CV delta T, right? And here I have to expand, and this CV for monoatomic will takes the value CV equal to, the value is 3 over 2 times R. So here I'm going to take this CV and substitute in this place. And this delta T, it's state 1 to 2, so I have to make a change in temperature T2 minus T1. So I'm going to expand this equation N multiply 3 over 2 times R, and here delta T is nothing but T2 to T1. Why? Because we consider the state 1 to 2. Now I'm going to substitute the value for getting the answer for the first subdivision. Clear? And here they mention the number of moles here is 2 multiplied by 3 over 2 times 8.314, and the temperature 2 they mention here as 600 Kelvin and T1 is 300 Kelvin. So 600 minus 300. So let me see what is the answer for this question. I got the answer for the first question as 7.48 multiply 10 power 3 joules. So this is the answer for the first question. Now we have to move to the second part, which is change in internal energy. So B part. What is change in internal energy? As we already mentioned here, from state 1 to 2, it's a constant volume, right? So if it is a constant volume, there will be no work done. So if you write the first law of thermodynamics, what is the first law of thermodynamics? Q equal to change in internal energy plus work done. This is the rule, right? And here the state 1 to 2 represent a constant volume, so there will be no work done. So if you substitute this work done equal to 0, the answer here, which is Q equal to exactly change in internal energy. As we already found the answer for this energy in the first part, so I am going to take the same answer for the second part also, because here when you substitute work done, which is equal to 0 here, what will happen? Q is exactly equal to change in internal energy. So what I'm going to do, as we already find the answer for the energy, I'm going to take the answer here. So therefore the change in internal energy is equal to 7.48 multiply 10 power 3 joules. Clear? So this is the answer for the second part. Understand? Okay. And in the third part, we are going to find the work done, right? And we already gave the answer in the second part. What is the work done? Because this is at constant volume, there will be no work done. There is no change in volume. If there will be a change in volume, there will be work done. But here at constant volume, the volume doesn't change. So what's the answer for the work done? So the work done for the state 1 to 2 is equal to 0. So this is the answer for the third part. That's it. Thank you.